Hi, I'm Thijs de Vrije. I work at the Swiss Federal Labs, and the aim of today is that I will present the so-called cooling selection matrix to you, which is a tool to compare different cooling technologies with this particular focus on use for smallholder farmers. The reason for this being that we developed this is that we often have difficulties of choosing the right technology because we don't have the full picture, the big overview of all the components which are relevant. So we tried to make something that could make this process of selection a little bit easier, which we would like to share with you today. So what I will talk about is what are the different evaluation criteria for selection of cooling technologies. There can be more. This is a compendium of stuff we put together based on our experiences, of course, but it should give already a good overview of the complexity of the problem. Then I will present the cooling selection matrix, how it looks like, and then on the last part, how to use it. Very important is that we provide this tool, this spreadsheet tool, also to you, so you can also download it. So please have a look, then you can try to use it yourself. So we came up with a list of important criteria which are relevant to selecting different cooling technologies. And I will quickly go through some of those. So first of all, you have to look at your use case, which producers are looking at, let's say smallholder farmers or even commercial farmers, more agricultural enterprises, which we're not targeting today. And which market am I looking at? The local market, export market, and so on. And how accessible is this market for my use case? So that's a use case question. There are a lot of aspects that are very much related to your use case as well, and it's very important that you would define those. For example, transport, infrastructure, crop seasonality, and so on, availability of technology and of produce, and are there some business cases that you could leverage in, let's say, selecting and deploying a cooling technology? Then, of course, local conditions and culture also play a role. So very important before you start with the selection matrix is defining your use case in high detail, that you know what you actually need, what you want to have. Then apart from that, you have other evaluation criteria with respect to the cooling technology as such. For example, on installation, what's the cost? Can I manufacture locally, or am I dependent on imported materials? At which location will I put my facility, or can I put my facility? Second part is also on scalability and adaptability. So which scale am I looking at? Can I scale to different farms, farming communities, and so on? Can I use the same technology maybe for other types of use cases? So is this multiplicable? Is it only a very customized solution for one use case, or is there a scalability? This is often important if you're dealing with a lot of humanitarian organizations, for example. Then, amongst others, you also have operation and maintenance issues. So how much expertise do I need to operate the facility? Can I maintain it myself? Can I monitor it myself? Do I need additional expertise? How costly is this, for example? How close would this maintenance staff be, and how available are those? Do they need to come from abroad? Are there spare parts available? And if I buy items, what is their quality? What's their expected lifetime? Do I have warranty on those? Other aspects are, for example, related to energy supply. Which energy do I have available? Do I need to rely on photovoltaics to supply energy for my cold storage room or my cooling solution? Is this energy supply, if it's, for example, from the grid, is this stable throughout the day? Do I have power outages, a lot of power outages? How long do they take? And what's the cost, for example, if I want to use the grid, if I want to use a diesel power generator, and what would be the cost if I would use photovoltaics, for example, because you might not need to import them. Apart from the supply, then we also have to see how this is, let's say, used, and if there are also energy storage systems available. As I mentioned, which power source do I have available? Do I have a backup power available? Do I want to store energy in a battery, so chemical storage, or do I want to store it with thermal storage, for example, if I use phase change materials? And how efficient is my cooling solution with respect to energy? Then with respect to cooling process, which refrigeration technology am I looking at? This is very important. What's the typical cooling time? And very important to understand is how do I transfer actually heat from the produce, so from the warm produced to the cooling medium is by conduction, convection, and so on. Often it's by convection in these cooling processes, but it's good to be aware of this. With respect to cooling performance, how much can I reduce the temperature? To which degree? How stable is the temperature throughout the day? And is there some kind of humidity control, or do I have to be a little bit mindful of that? And then finally, you're looking at food products. So you have different types of food products which need to be stored at different types of conditions. You have climacteric and non-climacteric fruit, which then or ripen after harvest or don't ripen after harvest. So it's very good to be aware of this. So these are all criteria which is good that you would evaluate them in order to be able to score them also with respect to the cooling technologies. So there are different cooling technologies here, which we can evaluate with our cooling selection matrix. You have them organized into actually, here 3 categories, but there are actually only 2 types of cooling technologies. You have the active cooling solutions, amongst others, walk-in cold rooms, refrigerated trucks, and trailers, or even small refrigerators, and so on. And then you have passive cooling solutions, amongst others, evaporative cooling, or underground cooling systems, or high altitude storage, and so on. So these are the real cooling technologies. Then the other third part, which I will not talk about today, are modulation and preventive technologies, which can actually help to dampen the heat fluctuations or temperature fluctuations during the day, or also make sure that you don't have so much heat load on your structure. That I will not talk about today, so because the cooling selection matrix is actually focused on the 2 types of cooling technologies, which you see there on the left side. Now, what is the idea behind this cooling selection matrix? Is that we have these different cooling technologies, all these different active and passive cooling technologies, which we map, and that we score them according to all these evaluation criteria, which I just mentioned, or most of them actually. And the idea is that we have then a complete overview, a visual overview, quantitative overview as well, that allows to compare different technologies for a specific use case or different evaluation criteria for let's say, different technologies. So the idea is that it could assist you maybe in identifying the most promising solution for your use case in an easier way by taking into account these multiple criteria in one overview, in one visual overview, compared to writing them in a long text. So it's rather a visual comparison, but also quantitative. You have to be aware of that. So it's a tool which might be able to assist you. I'll explain in a minute how it actually works. The scoring as such depends on the country, supply chain, but also use case. So you have to be aware of this. So if you would use this or score this selection matrix for every use case, country, and supply chain, it will look different. And that's the beauty of it, because for one case, a certain cooling technology might seem very viable, but for another use case, it might be not at all viable, as we will see from here. So how does it look like? Here you see a screenshot of the spreadsheet we will make available to you. So you have there on the one side all the technologies. So these are the different columns, active and passive cooling technologies. And then on the rows, you have the different types of evaluation criteria, most of which I just mentioned. And then on the bottom, you have actually also an average value. You would score them from 1 being positive, will light up green, to 5 being negative for all of these criteria. So as I mentioned here, you have here the in the columns the different, let's say, cooling technologies, and all of the ones which I mentioned are listed here. That's on the column side. Then on the row side, you have, and that's a zoom in here, you have here these evaluation criteria. And the idea is that you first do you look at your use case in detail, and that you're then able to score these different technologies according to these different evaluation criteria. So how to use it? Well, for example, I would do the scoring for, let's say, 2 types of technologies. I don't focus on all. Let's say I only focus on 2 types. Let's say a walk-in cold room, which you see there on the left. Then I score them. You see then all of the criteria lighting up in a certain color, red being not so good and green being very good. So scored 1 then, of course, and 5 would be not so good, which is then scored more on the negative side. And then you have, for example, an evaporative cooling solution, which you see then on the right side, which is scored in also in the same way. The nice thing here, if you look at this, is that it becomes completely clear for which criteria different cooling solutions actually perform good or bad. You see that the active cooling is a little bit more challenging with respect to cost and implementation, and it also has a little bit of more difficulties, so a lower or a more negative score in the operation and maintenance. On the other hand, if we look at the cooling process as such here, for example, it would be much better than the passive evaporative cooling solution because it just cools faster and so on, which comes at a cost. So there you can really compare, let's say, two technologies in a very clear way, and it's very clear what the advantages are of both technologies. So this I find personally very nice to compare different technologies. It's very specific to your use case. For a different country supply chain, the scoring will look different, maybe because you have better access to certain types of technologies, for example, or you have a lower import dependency and so on and so on. So this could make that, for example, active cooling is looking much better. If you would put a passive cooling solution in a country where you have a very, let's say, wet and not so warm climate, then the cooling performance of passive cooling will not be good at all. So then even this will turn out to be worse. So very specific for your use case. So that's why it makes sense to do the scoring. You can also compare different criteria for all cooling technologies. So suppose you look at installation and implementation, and then you score all different technologies, then you see that some of these more passive cooling technologies would be rather easy to implement for your use case, all fine, but their cooling performance, and that's another criteria, is much lower. So although it's easy to roll it out, your gain will be, let's say, much lower than you would look at for example, an active cooling solution, which has a lot of challenges with implementation and purchasing as well, but has actually is a very easy way to reduce the temperature. So you can compare different technologies. You can also compare different criteria for the different technologies. You can also compare everything together. So I did here a scoring for a use case we had in Sub-Saharan Africa, based on my expertise, and then you can compare everything. So you can also, let's say, compare different technologies according to all criteria. I find this personally very nice to have in one view an overview of all cooling technologies according to all criteria. Maybe it helps you too in evaluating your cooling technology. I call this a so-called fingerprint for our use case because it will be different for every use case you're looking at, and some technologies will come out better or worse than others depending on the use case. But this is in one view, one image, you have directly everything quantitatively scored. If you have an expert who knows all the technologies and knows roughly, did an analysis on which technologies would be roughly available, then you can do the scoring roughly in a time below 1 hour or 1 or 2 hours. It does not take days to put this together, given that you have an expert that knows the field a little bit of the specific use case. So this is a rather quick fix to have a lot of quantitative information in my view. What you can also do is have the average of all criteria. They're then all weighted with the same weighing factor, every of these criteria. Then you have an average for different technologies. Personally, because the weighing is for every criterion one, I would not rely too much on the average as such, because it's very well possible that there you have a killer criteria in one of the evaluation criteria, which makes that implementation is very difficult or that it does not make sense at all. So don't base yourself too much on this average, but this gives a rough overview of which technologies come out in a good way. But be very careful with using this average, I would say, because they're all weighted the same, and there are killer criteria which are not always taken into account. Take-home messages for this matrix. Please try to use it if it makes sense to you. You can score these multiple technologies according to multiple criteria and have in one view everything, in one visual view. So I find this rather valuable. Before you start scoring, please make sure that cooling is at least one of the right solutions for you. So I would always urge you to do maybe, if possible, a very simple post-harvest assessment. This is a method which was developed at Wageningen University and which we also deployed, to make sure that cooling is the right solution and that there are not other solutions that could, post-harvest solutions or even pre-harvest solutions that could be a better win-gain for your use case. If you then decide to go for cooling, you can use this matrix to see which cooling technology would actually be best for you. If you need more info, it's all described in our cooling atlas, so I would like to refer to that. So, and I would also like to urge you to use this cooling selection matrix if it makes sense to you once. That's it for today. Thank you.